Up to this point through lower level math and pre-algebra, we've really just been working with regular numbers like 3, or 0 or -7 plus, maybe some fractions in decimals. Now, in algebra, we're really going to need to start working with variables. So for instance, we most commonly use x or maybe y to indicate a variable. So if before algebra we were using almost exclusively constants, if instead of this we replace the 3 in this equation with a variable x, we can say x plus 2 equals 5. It's the same thing, except that now we have a variable in our equation. And just by matching these up, and because we know that we swapped x out for 3, we know that the value of x has to be 3. What do we have to add to 2 to get 5? Well, that value is 3. We'll talk much more later on about how to solve equations like this one and more complicated equations. But the idea for now is just that we're going to be using variables like x and y going forward as placeholders for values that we don't know. So in the future we might be presented with something like this. Just x plus 2 equals 5 and ask to find the value of x. So at this point, all we want to do with this lesson is define some key vocabulary terms. We usually use x or y to represent a variable, but technically we can use any letter that we want. These are just the most common. We also want to say that constants are the kinds of real numbers that we're used to seeing like 3, or -7, or in this equation over here, 3 or 2 or 5 are all constants. The next thing we want to define is the idea of an equation like this one that we wrote here. An equation is just this mathematical statement here that contains an equal sign. And what it tells us is that the value on the left side of the equal sign is equal to or equivalent to the value on the right side of the equal sign. So like we already looked at in this example, if this left side has to be equal to this right side because we've set up this equation, because we know these two things have to be equal. And so what we're trying to figure out is how we make this left-hand side equal to 5. And the only value of x that makes this left-hand side equal to 5 is x equals 3. But we define this kind of mathematical expression as an equation. If it has an equal sign, it's an equation that implies that the left and right-hand sides are equivalent or equal to each other. We also want to define at this point the idea of a coefficient. So we talked about variables as x and y. Here we looked at the variable in the equation. X plus 2 equals 5. Well, we can have a coefficient in front of the variable like we're showing here, 3x. So maybe we write a different equation. Let's call it 3x minus 10 equals 8. It's implied that the coefficient and the variable are multiplied together. So instead we might see something like this. Let's say a x squared plus bx plus c. So we have x here and x squared x is a variable. But a and b here are coefficients on the x squared and x variables. So a and b represent constant coefficients. Because it is kind of acting like the 3 is acting up. Here it's a coefficient on x squared. It multiplies x squared. So this is a times x squared. And it is just holding the place for some constant. On x, we usually use letters at the beginning of the alphabet like a and b to represent constants or constant coefficients. In contrast was usually using letters near the end of the alphabet to represent variables. We also have here expressions, and we can kind of think about expressions in contrast with equations. Equations always contain an equal sign. Expressions don't. So an expression is really just a group of terms. The negative sign, the subtraction, is an operator between the two. Putting them together creates an expression, and expression is a very broad term. We usually use it to identify just any kind of mathematical expression that's not explicitly an equation with an equal sign. So even within this equation we could say x plus 2 is an expression. Usually we use expression to indicate more than one term, but we can still use it to indicate a single term. There's no equal sign here. So expression is this very general term. It's just what we use whenever we don't explicitly have an equation with an equal sign. And we've also now introduced this other language, this other definition, which is the definition of a term. And a term is just any single number, or variable, or numbers and variables multiplied together. So in this expression here, a x squared is one term, bx is a term, c is a term in this equation, 3x is a term, 10 is a term, 8 is a term. Over here we have examples. 3x squared could be a term. Bx could be a term negative. 1 is a term of either a number or a variable or a number, and variable multiplied together, or a constant and variable multiplied together. So just as an example, if we were to consider this equation, 3x minus 10 equals 8, and walk through all of these new definitions that we have, what can we say about this equation? Given that we now have all this new vocabulary, we know that x right there is a variable. In contrast with that, we could say that 3x minus 10 is an expression. We could even list any one of these terms individually as an expression. But again, typically an expression is a collection of more than one term. So calling 3x minus 10 an expression from this equation is probably the best use of expression when we're looking at this equation. But we can also identify the individual terms 3x, 10 and 8. Those are all terms in this equation. We could recognize that the coefficient is 3. The coefficient on the variable is 3, and that we have constants here of 10 and 8. Because individually here we have 10 and 8 in the equation. So all we want to take away here is this idea that we're going to start replacing real numbers with letters instead, and that we call those letters variables. Variables are attached to this idea of constants. Because we distinguish between a variable and constant, we see variables appearing in equations and expressions. And we now know the difference between an equation and an expression. And we know that variables can be part of individual terms, but that terms don't necessarily have to contain a variable. A term can be just a variable, just a constant, or a constant multiplied by a variable.